you want to hit the broadcast.
Hello, and welcome to the September 16th vBrownbag US. Today's topic, we're going to discuss configure and administer advanced vSphere 6X storage. Your presenter tonight will be Niran Even-chen. My name is Chris Williams. If you want to get in on the conversation, you can talk on the chat channel, or you can use the hashtag vBrownbag. We'll be monitoring both. Tonight's guest is, I said, Niran Even-chen. He's at Niran EC. His website is cloud-abstract.com. My name is Chris Williams, and also hosting is going to be Imad Yunus tonight. So welcome to the chat, and let me change it over to Niran.
Thanks, Chris. That was quick.
Sorry, was that too fast? Should I do a little tap dance first?
All right. Let me see. Show my screen. Okay, you guys seen my screen?
Yes, we can see it.
Awesome. So yeah, we're gonna talk about Objective 3, but more specifically about Objective 3.5, set up and configure storage I/O control. As Chris mentioned, my name is Niran Even-chen. I am a staff solution architect at VMware. I work for the Global Center of Excellence, currently focusing on Microsoft business critical applications running on VMware platforms, whether it's vSphere or vCloud Air and so on. I am very proudly to say that I'm also VCDX DCV number 142, and also I am a VCDX panelist. I'm also a vExpert, so I'm part of this community. I've been learning from the community, and I'm very happy to give back in this session today. I'm a former VMware certified instructor, so for about 9 years I've been teaching VMware courses kind of as a side gig, alongside with consulting, obviously, and stuff that implementation and design. But I've been teaching VMware courses since the earliest versions, since the 2.01, 2002, 3, kind of until like 3 years ago. My website, though not hugely active, is cloud-abstract.com, where I write from time to time, technical stuff. And more active than that is my Twitter account, Niran EC. And just to mention, I'm here as part of the community, not as representing VMware or any such thing. Here to give back to the community that helped me along the line, and to give back to people that want to learn VCP. So the objective for this subject for setup and configure storage I/O control, I did a copy paste from the blueprint from the VCP6-DCV blueprint, and the requirements are basically to talk about what storage I/O control is, describe the benefits, how to enable and configure and manage it and monitor it. There's another point to differentiate between storage I/O control and something called dynamic queue depth or adaptive queuing, and also to talk about what happens when there's no storage I/O control, what happens with I/O, and so on. Now, I'm not here to go over the test or to teach anyone how to pass the test. We're here to deliver a subject. So I created my own agenda for this session, which is more logical to learn the storage I/O control subject. So we're going to go over what is storage I/O control. Then we're going to talk about what's new in version 6. I'm going to go over the requirements for storage I/O control, what unsupported configurations. I'm going to touch on the subject of what is storage I/O control and what is adaptive queuing and what's the difference. I'm going to obviously do a demo of how to enable, how to configure, and how to monitor storage I/O control. And then I have another slide with a few resources that might be valuable to people that are looking into this subject or to learn it for different reasons. So let's go into the storage I/O control. So some of you might have seen this graphic before that explains what storage I/O control is. And basically, storage I/O control is a technology that allows us to prioritize access to shared data store. So situation that you have a data store, an NFS or VMFS data store, and multiple VMs from multiple servers are accessing it. and you want to prioritize access. The way we prioritize access to these VMs, we do that based on shares. Just like we do it on CPU and memory, we do it for storage with storage out control enabled, while the granularity is actually on the VMDK level, right? So we set the shares on the VMDKs, and in that way we prioritize access to the data store. Storage out control also provides the ability to set limits and reservations, and this is new in version 6, and I'm going to touch on that in the next slide. So what we see on the screen here on the left side is what happens when we don't have storage out control. Now think about the situation that you have multiple VMs working for multiple servers. All these physical E6i servers needs to be managed by a single vCenter, but they're basically accessing a single, let's say, VMFS in this case. And let's say 2 VMs in this screen are hammering the data store in a way that the latency goes up and causing other VMs to suffer. And these other VMs might be, more critical VMs, right? So we don't want that situation to happen, obviously. And the way we manage that is by using storage out control. And once it's enabled, let's say there's this situation, and this situation can happen for multiple reasons, right? It can happen for either bad planning, or it can happen from unpredictable situations like a virus that's hit, that's touching your VMs and creating a lot of I/O for the data store, creating a lot of pain for anyone that's trying to access that data store. Or in a situation that maybe your company just purchased a subsidiary company and nobody told you that one of your services is going to be overloaded. So in these situations, there's something that happens. Now, with storage out control, we set a threshold, a latency threshold, that once it's been passed, storage out control kicks in and start to prioritize access to that data store. And access is prioritized based on the shares, limits, and reservations. Now, the threshold that we set can be set in 2 ways, and I'm going to touch on that more deeply when we get to the configuration, but basically we can set the threshold manually, statically, and go and set, let's say, a threshold of latency of 30 milliseconds, which is the default when you set it up manually, or we can set it up dynamically. And it's using a mechanism called the I/O injector. Now, when we set the dynamic threshold to a percentile of the capability of that data store, let's say default is 90%, there's a mechanism called I/O injector, and what it does basically, it's injecting I/Os, random I/Os to the data store, and it does that only when the data store is idle. We don't want to, even though it's running on a 30 millisecond cycles every 24 hours. It will do it only when the data store is idle. It will not create more load on your storage device just to test it, but it will run this I/O injector and will come back and say, oh, this is the latency that I see. I see this, the storage, the minimum latency, let's say the lowest latency it can achieve. It's 10 milliseconds, for example. So if we set the dynamic threshold to 90%, what will happen is that at 9 milliseconds, when latency goes up at 9 milliseconds, then storage out control will kick in and will start, managing priority, who gets access to the storage and who's not. Obviously, VMs or VMDKs that get more access get more throughput and less latency, and VMs that get less access get less throughput and latency goes up, and it's very accurate and proportional to the amount of shares and other settings you set. So I want to touch a bit about what is new in version 6. So in version 5.5, VMware introduced a new IOPS scheduler called the mClock, which is better IO scheduling than what VMware had before. But also what it allows is to set reservations or guarantees of IOPS for specific VMDKs from a data store. And the new feature called IOPS reservation is set not through the GUI, it's set through either advanced parameter or through the API. So you need to go and change the configuration file of the VM to set the reservations. Now, in addition to set the reservations themselves, and I'm gonna show basically how it affects the way IOPS is being distributed. But in addition to that, the IO injector that I explained about before also was adapted to not only to check the latency of a specific storage device, but also to sample the amount of IOPS that storage device can give. It does that by using, if I'm not mistaken, 4K random read IOPS to check to see how much IOPS that the storage device can give. And that information from the IO injector is used in several ways. The first thing it does is storage DRS basically does something called initial placement. So when you power on a VM, it can power on the VM on the specific data store that can accommodate for the reservations if you set it. So for example, you set reservations for a specific VM and you power it on. Based on the information from the IO injector, it will know, where to place the VM. But more than that, it also controls the way that the scheduler is going to distribute IOPS. And let me touch on that. So there's a blog post that came out just not too recent and not too far from today, just about that. So I'm going to touch briefly on that for 10 seconds here. Let me just open that. It has nice graphics, so I'll just use that to explain. But here's a situation that we have a storage device, and the IO injector checks to see what's its capabilities. And it sees that it can accommodate 8,000 IOPS. Now, there's multiple VMs running on this device for multiple servers, and each one has its own amount of reservation, a number of shares and limits. And as you can see, the amount of reservations does not exceed the amount of IOPS that this device can give. So from a reservation perspective, there's no problem to accommodate the requirements of the VMs or what is set on the VMs. So if the storage latency, the storage IO control latency has been crossed and it needs to start distributing IOPS, the way it will do that, it will take the amount of shares, the total amount of shares all the VMs has, and will divide it by the number of shares each specific VMDK or VM has. And based on that, it will calculate the percentage that the VMs is entitled to, and then it will take the amount of IOPS that the storage device can give, which is 8,000, and will give that each VM the proportional amount of IOPS it can get from the amount of shares it has. This is exactly what happened in previous times, and this is also what's going on with CPU and RAM CPU and RAM reservations shares. Now, another scenario is that let's say this data store or this storage device can now accommodate less IOPS than what the reservations of all the VMs that are accessing it has. And this can happen for multiple reasons. Either you set over reservations for the VMs, or you added VMs, or the storage device got slower. The IO injector checks that. And what happens in this case is instead of taking the shares, it will take the amount of reservations, the total amount of reservations that all the VMs that access in the storage has, and will divide it for each VM for the amount of reservation it has. We'll take that percentile and we'll calculate from the total amount of IOPS that the storage device can give and the percentage it will give each VM the amount of IOPS it's entitled to. So instead of using shares like in the previous scenario, in this case that is over reservations, it will give each VMs the IOPS based on the amount of reservations it's configured with. So this is the change in version 6. That basically introduced using the new reservations, the new scheduler, and the reservations. The reservations. So, in regarding to requirements to have storage IO control enabled in your environment, the first thing, and this is like a general thing with storage IO control, it needs to be able to control the workloads that are accessing the data store that is supposed to, it's supposed to distribute IOPS on. So the storage IO control is a vCenter construct, meaning it can manage VMs from a specific vCenter or VMDK from a specific vCenter. So if we have workloads that are external to that, like let's say are managed by a different vCenter system, storage IO control cannot manage their I/O throughput and their latencies. Therefore, it's not supported. So we should not have that. I'm going to touch on that specifically in the next slide as well. Storage out control does support fiber channel, iSCSI, and NFS version 3. In version 6, VMware introduced NFS version 4, which is currently not supported with storage out control. RDMs and extents, which I have no clue why anyone would use extents these days, but if you have that, is not supported with storage out control. Now, in regarding to auto-tiering meaning the storage devices that has multiple tiers of storage, let's say SATA, fiber, and SSD. In regards to auto-tiering, many people think that this does not work with storage out control, and that's not true. Storage out control can work with auto-tiering in conjunction together. The one thing you need to check is to see with the storage vendor and the SAN compatibility guide from VMware to see that both are compatible with one another. Which, as far as I've seen, most storages that do have auto-tiering do support that with storage out control. Now, besides support, the question is, should I use storage out control with auto-tiering? Why do I need that? And, storage out control does complement auto-tiering. There's different kind of technologies of auto-tiering. Me specifically, I'm more familiar with the EMC, for example, that has, the VNX auto-tiering, the VNX fast, and the VMAX fast, which works differently, right? Like any other storage that has different auto-tiering technologies. Now, vMax, for example, works in real time. So there's the fast technology, the auto-tiering technology in the storage is supposed to take care of any latencies that occur. So if there's a specific data store that some blocks are very hot and it's causing latencies for workloads, auto-tiering is supposed to move these blocks to faster storage, and blocks that are less accessed supposed to move to slower storage, right? This is basically what auto-tiering does. But there could be situations where there's misconfiguration or where the auto-tiering technology is not real-time and it's not responsive in the right time, or any other situation that causes auto-tiering not to respond at that time. What is your fallback in this situation? This is where storage out control can become very handy, because if your auto-tiering fails you, storage out control would come in and pick up the slack and basically save you from a bad day in IT land, right? So in this situation, let's say there's fast auto-tiering from EMC or any other technology from IBM, HP, or whoever. I'm just familiar with EMC, but there's an auto-tiering technology, and we set storage out control to the highest latency that the slowest tier of that auto-tiering can give. So, for example, let's say the SATA, we're going to set storage. The SATA tier can give you latency of, let's say, 15 milliseconds, and we set storage out control to 30 milliseconds. If auto-tiering fails you and it gets to 30 milliseconds, then that's the time the storage out control will start working and will save the day. So it does work with auto-tiering. There's only one main caveat: is do not use the IO injector and use a static configured threshold. Because if you're going to use the IO injector, it's going to use random IOs to check to see what's the capabilities of the data store. And one time it will check and will touch maybe one tier, and one time it will touch faster tier. So you get unpredictable results from that. So you can't really set the right percentile. So better use static. This is the way, static threshold. This is the way to do that. Hope this makes sense.
Yes, it did.
So in regards to what's unsupported, and I already started touching on that, anything that is what's called external to storage out control, which is basically ESXi servers and virtual machines that are part of a different vCenter, or ESXi servers running older versions than 4.1, God forbid, that before storage out control was even introduced, or physical servers that are accessing the same physical devices, physical disks, or maybe even the front-end ports of the storage device that your VMs that you're trying to protect with storage out control are accessing. And if there's an external workload like that.
Hi, yes, we've got our first question of the evening.
All right.
The question is, what is the minimum VMFS version for SIOC in version 6.0?
I'm not sure. I'm pretty sure 3 does work, but version 5 is VMFS 5 was the VMFS that working with version vSphere 5 and vSphere 6. If you haven't upgraded to version 5 VMFS 5 when you move to vSphere 6, then storage out control is the least of your problems. So I would say VMFS 5 is something that you need to use, right?
Makes sense. Okay. Yep. Okay. Second question just popped up. With I/O injector, does it work with storage array that has flash cache? What if the I/O injector keeps hitting the cache?
So using flash or caching is just like using auto tiering. It's basically multiple tiers. I would check, first of all, this is my answer, and my answer is check with your storage vendor what is their recommendation for storage I control, okay? Even cache is used differently in different storage systems, so I can give you like one answer that hits all. But being that said, if you can't really predict what would be the I/O you're going to get, because one time you're going to hit the cache and one time you're going to hit the spindles, then use static threshold.
Cool. Okay.
Sense?
Yep, it sure does. Thanks, Niran.
So, going back, in a case that you have external systems that are causing latency for your VMs by loading the disks or loading the front-end ports or loading the data store in any way that storage out control cannot control, then what it will do, it will stop working. This knowledge base at the bottom of the screen basically explains the error message you're supposed to see. Sorry, but storage out control will detect an external system and will stop working. And as soon as it sees it stopped working, for the reason is that if it will start throttling down the VMs that it can control, the external system will start taking more and more throughput from that device. Without storage out control can do anything about it. So it will lower its control, allowing its environment to take more IOPS, and as soon as it detects the external system goes away, it will come back working. So you shouldn't use storage out control in environments that you're sharing a physical device on the storage with external systems that are not under the control of storage out control. You shouldn't. But it's not that it's not possible, right? Because if storage out control does not detect that external workload, it will go back to working. Follow this knowledge base for supported configuration and unsupported configurations. Now, in regards to that adaptive queuing or dynamic queuing, what is that? So adaptive queuing is a technology that exists in E6i in any version. It's part of the E6i storage stack. And basically what it is, it's 2 advanced parameters, disk queue full sample size and disk queue full threshold. Disk queue full sample size, if you set it, for example, to 2, when the E6i server gets a sense code from the storage device of queue-full or busy, the number of times that is set on the queue-full sample size, what it will do, it will go and cut the LAN queue depth of that device by half. That would be for anything that accessing this data store, right, from that E6i servers. This is not granular on per VMDK or per VM level. This is like for everything that accessing that data store from that server. And by cutting it by half, it basically throttled down access to that data store because it shows that it's full. Now, once it shows sense code of good sense code of healthy, that reaches the number of queue full threshold. Let's say you set 3, and you see it gets I'm good 3 times. Then it will start one by one increasing the slot size of the E6i server. Storage I control, on the other hand, you set up the shares on the VMs, and when the threshold is being passed, is being crossed, what it does, it basically goes and reduces it basically calculates all the shares of specific VMs on the specific servers. So let's say this is a physical server that has 400 shares, and there's another server that has 1,000 shares, right? Or let's say 1,000 shares and 2,000 shares. So the server that has 1,000 shares is going to get half of the queue size of the queue depth long queue depth that the server that has 2,000 shards gets. Once it throttles down on an ESXi server level, then the ESXi server local I/O scheduler will distribute the IOPS based on the VM shares. So the granularity is on a per VM level, even though it touches the same parameter of the long queue depth. The granularity of distribution of IOPS and the throttling of IOPS is based on a VMDK level, whereas an adaptive queuing is on the entire LAN. So the granularity is the first difference between the two technologies. The trigger is the difference, right? The trigger on storage I/O control is the latency threshold, and the trigger on the adaptive queuing is the queue full or busy sense code. And the way you configure it, storage I/O control is configured from the vSphere client, and adaptive queuing is configured using advanced parameters. Except for storage I/O control version 6, the IOPS reservations is set also in advanced parameters in the VMX file of the VM. And there's a license. Storage I/O control is licensed with Enterprise Plus, while adaptive queuing exists in ESXi server in any license. So I think this is time to go into the demo. Let me jump into my demo environment here. This demo environment is in our office in New Jersey. So let's start by configuring storage I/O control. So we need to go to the storage configuration of the server. I have only a single data store here on Tintri storage. I'm sure you might love to see that. So we go to that shared storage that we have multiple VMs on, and we go into the settings, and we hit edit on the data store capabilities. And here we have the option to enable storage I/O control on this specific data store. Once we enable the storage I/O control, we can set the threshold. There's two ways to set the threshold, as I mentioned before. We can set based on percentage of peak throughput. Default is 90%, and this will use the I/O injector. I can tell it the I/O injector is also used not only for storage I/O control, it's used also for storage DRS. Storage DRS can do storage vMotions based on I/O latency of VMs. We can tell it not to send information there or not. Or we can set the storage I/O latency threshold manually, let's say for 30 milliseconds, like I said, to do on auto-tiering storage devices. So we can set it, we'll set it to 30 milliseconds. Unfortunately, I didn't have time to actually go and create load. So when I show the monitor, I'll show the right screens, but I won't have actual load to show. But then the next thing to do is actually to set, shares on the VMs, right? So if we go here into related objects.
Niran?
Yes.
We have a quick question. Based upon config parameters, I assume adaptive queues do not work with NFS data stores. I think the previous screen that you had proves that incorrect.
I'm not sure. I'm pretty sure. I don't want to give a wrong answer. I'm not sure here about the answer about NFS.
The data store that you were on was NFS, wasn't it?
The data store that I have here is Tintri, it's NFS, but I didn't work with adaptive queuing here.
Okay, all right.
Okay, so just storage I/O control.
Gotcha.
So here we see all the VMs. I have many VMs here. We have a lot of stuff going on in this specific lab. But what we can see here is the share value for all the VMs. And we can also see the data store percentage of shares. So since I have many VMs, you see the percentage each VM has from the amount of shares. It's very small, but if you can imagine much smaller amount of VMs, for example, then one VM might have 25% and another VM might have 50%. And this percentage just means that if, let's say, all the VMs are trying to hit the storage and get 100% of the amount of IOPS and the smallest amount of latency, then storage I/O control, once the threshold has been passed, will start distributing the IOPS, the IO, access and the throughput based on that percentage. Obviously, the situation usually is not that all the VMs are competing with one another for all the resources. So, vSphere is smart enough to set to work with the amount of shares to set the right amount of IOPS and latency to the VMs. It's very accurate the way it works. Now, how do we monitor this? Well, first of all, how do we configure the shares? The shares are configurable from the settings of the VM. So if I go and set edit settings on VM, on each VMDK, we have the ability to set the shares here, right? The ability to set the shares here, and by that control the prioritization. And we have the ability to set the limits here, and as I said, reservations. And there's a good blog article from William Lamb that talks about how to configure the reservations in version 6. It's fairly new, so not a lot of people actually know about it, or even if they know, they're not working with it, but I assume it's going to get more traction as we go along. Now, once we set the shares, we want to monitor it. So if we are on the storage device that has storage I/O control enabled on, we're going to go to the Monitor tab. I'm going to hit Performance here. And we're going to go into Performance. And we have a few counters here. The first one is storage I/O control normalized latency. What does normalized mean? Because different workloads create different sizes of I/O. So we don't want large I/O, for example, to be considered as higher latency. Basically what it does, it weights the size of I/O and normalizes it so that it knows the right latency to consider, and not just thinking because VM sends really large I/Os, it's higher latency and so on. So it will know how to distribute I/Os in the right way. Storage I/O control aggregate IOPS basically is the aggregation of IOPS of all the VMs that are accessing that data store from all the servers, obviously. And we can see here there's, where's that? Max QDEPs per host. Where is it? Oh yeah, missed it here. So basically, if storage I/O control would start working here, this is where I enabled it, right? But storage I/O control will drop. Well, the QDEPs will drop once storage I/O control starts to throttle down different servers. There's also a clip that, well, let me get to that. So additional resources. From the resources that are detailed in the VCP-DCV6 blueprint, the one that has the most information about storage I/O control is the vSphere E6 Resource Management Guide. This is where you're going to find the most information from all these guides about storage I/O control. On this YouTube video, VMware goes through how to enable, how to configure, and how to monitor storage I/O control. So it's pretty helpful if you want to see, in 4 minutes exactly what to do. Kind of the same stuff that I showed here in the demo, just with actual VMs that create actual latency. There's this great article. Well, anyone that's interested in storage and virtualization needs to read Cormac Helgen's, just like it needs to read Duncan Epping's blogs, right? So Cormac has a good article about adaptive queuing versus storage I/O control, and also have a great article about the workload injector behavior, so how the injector works. Pre-vSphere 6 though, but lots of useful information there. This is William Lamb's Virtually Ghetto blog post about how to set the IOPS reservations in version 6, and here's the knowledge base that I showed the graphics from about how distribution of IOPS is being done when reservations are set in version 6, in vSphere 6. And that concludes this, well, what I prepared for this session. I hope this was helpful for anyone that's going for the VCP6 and beyond, people that want to work with storage I/O control. And you can hit me with questions on my Twitter account or meet me in community events. Thanks, Chris. Thanks, Imad, for this opportunity. I really enjoyed giving back to the community.
Very cool. Thank you, Niran. Thank you very much. Oh, we have an echo in the call. Imad, is that you? Nope. Oh, there we go. It's fixed. Maybe not.
All right. Do we have any more questions?
I don't see any in the list now.
And there's one on Twitter. So
nope.
you want to go ahead and stop the recording?
Okay. Recording is now.